So, guys, today, yeah, I'll request everyone to just mute yourself. Okay. So, guys, today we are going to discuss about the Palo Alto packet processing. So far we have seen packet processing. Palo Alto has also provided the packet flow diagram, on their website, and multiple trainers are teaching you about the packet processing. But there are multiple things which are still unclear, because uh, when you see packet flow at high level, you're able to understand the flow, but how parallel processing is working, how it is getting executed at chip level, what are the exact steps PAN-OS is taking to do your packet processing. So today we are going to discuss everything in detail, right? So the agenda is quite simple. First, I'll walk you through my profile summary, right? Who I am, and what expertise I have got in multiple technologies. Then we will deep dive into packet flow of PAN-OS, and we will see how packets getting scheduled at hardware level, and then how your CPUs are doing the processing on it. And then we will see the real-time debugs analysis. I mean, I've already taken the dump of the CPU, and I'll walk you through the logs, how it is actually processed. So whatever we are going to see in the whiteboard, we will try to match it that actually this is the way it has been implemented within the PAN-OS, right? And then at last, I'll take your questions. Okay. So if I talk about my profile, I started my career as an implementation engineer in one of the MNC, right? There I used to work on Cisco routers, Meraki, and WAN optimization devices. I used to take care of the configuration part, right? And then I realized after some time I realized that this is not going to work for me. It's like not the role I'm looking for. So then I decided to move into tag, and then I started my tag journey, and after some time got promoted as an escalation engineer there, and then joined another tag as lead trainer, and there I got opportunity to train more than 300 tag engineers, and as well as 30 plus trainers who used to shadow my batches across the globe. So later on, I joined another tag as master trainer, and then I became the lead TDA in another big MNC, and delivered multiple projects for global organizations. On technologies like Zscaler, Palo Alto Prisma, next generation firewalls, endpoint security, SD-WAN, Cisco VeloCloud, Fortinet, Prisma, and Versa, right? And finally, I have become senior architect, you know, and I'm looking after the digital transformations for global organizations, right? So basically, I'm helping organizations to adopt the SASE and ZTNA frameworks, along with the multi-cloud and internet-first strategies, because this is the goal for organizations going forward, be it India, be it outside, right? So all the CIOs, CXOs, they are starting their internet-first and cloud-first strategies, and to go with internet and multi-cloud, we need SASE framework and ZTNA framework to be in place so that you can securely architect your overall solution, right? Then let me just present my whiteboard. Whiteboard is visible to everyone, right?
Yes.
Right, it is visible.
Yeah, Rohan.
Okay. Okay. So, so packet processing is like this. Let's say we have this Palo Alto firewall, right? And your LAN interface is Ethernet one by one, which is connecting to your LAN switch, and then we have LAN users, right? And we are calling it out as trust. Okay. Now, if this user would like to access Facebook.com, right? So the first SYN packet will be received by this interface in the Palo Alto firewall. And then firewall will do some sort of processing, and then it will send it out over the internet, and then Facebook will receive it, and Facebook is going to reply back with the TCP SYN-ACK, and then acknowledgement will be sent, your TCP connection will be established, then your SSL handshake will take place, and you will see the Facebook.com. But how exactly Palo Alto is doing processing? That's the question. Okay. So when we see the hardware components within Palo Alto, so you will see something like this. I have taken reference of 3000 series and 5000 series. Okay. because we have more complex models like 3200, 3400, 5200, 5400, 7000 chassis, right? So this hardware chip level goes very complex in those models. So just for simplicity, I have taken the mid-range box, how it is going to be, right? So these are your physical interfaces which are connected to this Marvel chip. Now, this Marvel chip is nothing but you can think of like a multiplexer, you know, which is helping to connect all these physical ports with the internal components within the motherboard, right? Then Palo Alto has designed this particular FPGA, field programmable gate array, and we also call them ASICs. So these are application specific integrated circuits, which help to boost the processing. We all say that Palo Alto firewalls are very fast. Why they are fast, right? So this is the answer to that. So we also call them network processor, and it depends on model to model. In 3000 series, lower end you will see Liger, and in higher ends you will see Tiger chip, right? So this is the network processor, and we do use it to offload the sessions to save the CPU cycles, right? I'll talk more about it later on. Then we have this DP CPU, the actual Octeon chip, which is going to do the packet processing for you. Okay, so it does packet processing in multiple stages. First is your ingress stage. Then we have flow lookup. Then we have slow path. Then we have fast path. Then we have app ID, right? And we have CTD. And at last, we have your egress stage. These are the multiple stages in which your PAN-OS is going to do the processing. Now, whenever there is a need for the signature match or any pattern match, this DP CPU will back and forth communicate with this another chip. We call it signature match chip, right? So in lower end, it could be Ocelot. In higher end, it could be Jaguars. So these chips, be it network processor, DP CPU, or signature match, it could be in multiple numbers as well. I mean, on lower end boxes we see only one chip here, one chip here, one chip here, but in higher end boxes you will see multiple CPUs, multiple cores, multiple signature matching engines, right? In fact, if you have SFP plus ports, then this Marvel chip is not going to handle it. We have Petra, we call that chip as Petra, which takes care of your SFP plus ports, So your SFP plus ports are directly connected to that chip, okay? And then we have fat pipe from Patra towards this DP CPU for the processing within the board, okay? So now, starting your packet flow. So when this packet is received by the DP CPU, right, how it is going to start the processing? So first, we are going inside the ingress stage. So this is your slow path this is your SYN packet processing, right? So this is the SYN packet we have received on the firewall on interface Ethernet one by one, right? So first of all, this packet will be received on the interface, then it will be provided towards the DP CPU for processing. Now, first step is to take out the basic information out of it, like L2, L3, L4 information to form the six tuple. You know. Now, what are these six tuples? Nothing but source IP, source port, destination IP, destination port, protocol, and source zone, so that we can generate the flow keys. Why do we need flow keys? Basically, whenever any packet comes in, these are these stateful firewalls. So we, create the sessions for the connection, and we associate ID to them. Now, each session is going to have two flows keys. One flow key will belong to client to server packets, and another flow key will belong to server to client packets. Okay. So it is going to be like this. From firewall perspective, whosoever is initiating the connection will become the client, and whosoever is responding to that particular request will become the server. So client to server flows and server to client flows are from firewall perspective. So basically what happens at this stage, firewall is going to take out the six tuple information, and then it calculates hash out of it. It generates the hash and stores it in the database. So basically, Palo Alto uses MongoDB to store your information, right? The database name is MongoDB. So we have SQL databases, likewise we have MongoDB. So the information will be stored at your database. For client to server, it is easy. We can extract the information because we have received the packet. But how we are going to calculate the server to client at the very first packet? So it is nothing but the reverse of your incoming packet, right? So if I talk about your incoming packet, it is having source IP, source port, destination IP, destination port. We have your protocol number, TCP, and we have your source zone, right? Now, to calculate the server to client, what it is going to do, it will swap these fields, right? So destination IP, destination port will become source IP and source port for server to client flow. This is client to server flow, right? And your source IP and source port will become destination IP and destination port. And protocol will remain same, and your zone will change from trust to untrust, and here it will be untrust to trust, right? Likewise, it will calculate the hash and it will install it inside the database. Okay. Now, when we extract this particular information from your packet, first it checks for ingress process error. Now, what is this ingress process error? So it's like your Ethernet frame, so when it travels on the wire, we have preamble, then start frame delimiter field is there, and then your Ethernet frame start. So basically when it is traveling on the wire, so it's nothing but 1 and 0 stream. Basically current is there, current is not there, right? So preamble being the first 7-byte field, it tells the receiving device that Ethernet frame is going to come, right? So it's like a honking system, right? And then after 7-byte information, we have this 1 byte information. We call it SFD, start frame delimiter, which tells that after me, your actual Ethernet frame is going to start, right? So during the parsing, once we have received the packet, we do the reconstruction. During that reconstruction, if PAN-OS is not able to read the information properly, in that case, there could be the process error. So if there is any process error, then we are going to drop those packets. And it happens a lot when you take the packet captures on Palo Alto firewall. And if you're not able to see the packet captures, be it in receive stage, transmit stage, firewall stage, drop stage, then there is one another option which says parse stage. If you check that particular setting, then only you're able to see all those packets which are getting dropped due to parsing error. Okay. So if there is no parsing error, then your packet goes to the DOS block table check. So it will check whether this IP has been blacklisted, because of the DOS policy. If it has been blacklisted, then the packet will be discarded. If not, then it is going to check this particular thing whether firewall inspection is applicable or not, right? If yes, then again it will check whether this packet belongs to IPsec tunnel, SSH connection, SSL VPN, or GRE tunnel, right? If yes, then it will perform the decapsulation. It will first verify in case of IPsec, it will first verify the hash. It will decrypt the packet. It will decapsulate it. In case of SSL, it will check the hash and decrypt it. In case of GRE, it will check the hash and decapsulate it. And then again, it will take out the original IP datagram and send it back to this particular processing unit. And it will again extract the actual L2, L3 information of that IP datagram. And then again, all these steps will be checked, right? And once this decider will say that now it is not a tunnel packet, it is the actual datagram, then it will be passed on to the flow lookup stage here, where we are going to check, do we have any existing session for this particular packet, right? So whether this is the subsequent packet, yes or no. So if we don't have any session ID allocated yet, then it will go towards the slow path. So basically firewall is telling this packet, let's create a session for you so that subsequent packets can directly take the fast path, right? Now we don't have any session ID created for this SYN packet, so it will enter into the slow path. Inside slow path, we do firstly we do zone protection profile check, and we are going to do TCP sanity checks. So basically, what zone protection is going to do, let's say you have configured the profile, for your flood attacks, your protocol attacks, your port scanning and all that stuff, right? So if any of the profile is taking hit for this particular packet, any anomaly is detected or any error is detected, then your packet will be discarded, right? So in zone protection, we have multiple options to detect this, right? We have random early drop algorithm. We have, TCP SYN cookies. So it is for TCP sessions only, right? So if any anomaly, any error is there, then it will be discarded. If not, we are going to perform the TCP state checks, right? And if everything is good, then we are going to enter into the IP user and user group cache. So, we are taking this scenario like this is the fresh setup, first time firewall has boot up. So these cache are empty at present. No data is available in cache, right? So why we have created these cache? These caches are there in place to expedite the processing. Okay. So, basically it does look up in the IP user and user group cache to identify, if this user is there, and it checks, whether user ID is enabled on this particular zone or not, ingress zone, right? Then it checks if this matches to any predefined application, basis on destination IP, destination port, destination protocol, right? So, initially, since this is the SYN packet, and we are assuming that this firewall is booted for the first time in the environment, so we don't have these cache available, and then directly it will go into the forwarding lookup. Now forwarding lookup is nothing but it is doing the route lookup for you, right? So it will try to find it out the egress interface, right? So we have this ingress interface because we know from on which particular interface we have received this packet. Now firewall will try to understand from which interface it will go out, right? So we will try to get the egress interface zone, your vsys, right? And then it will also do the policy based forwarding lookups, and if it is okay. So we have participant raising hand. Yeah, please tell me.
Uh, yeah. Hi, Ron. Devi
Yeah,
here.
yeah.
So in the application check stage, like in the step 3, like do we only check the matlab, service port or the application also? Like what are the application it's been detected in the third stage?
Yeah, so see, I'll come to this point when we will go through the application identification process, and I'll let you know how these caches going to work, right? Because it will be too early, otherwise it will, spoil the flow. Okay, so I'll get
Okay,
back to you on this.
okay, okay.
Yeah. So so it's in packet. It enters into the forwarding lookup. We checks for the egress interface and vsys information. We check for policy-based forwarding if we have configured it, and we are going to skip the TCI packets. That is your tunnel inspection, policy. If you have configured, we are going to skip those packets, right? And layer two lookup we are going to do. And after that, if there is no route or PBF is configured for your packet, it will be dropped, right? So what happens, you see in firewall, when you go into monitor logs, you're not able to see the traffic logs, right? Uh, you got the ticket that user is not able to browse facebook.com, and you're not sure how to troubleshoot that problem because you're not able to see the logs in the monitor traffic logs, and you're not even able to see the sessions, right? So when you check session browser, you're not able to see the session as well. So why it is happening? Because there is no route or there is no policy based forwarding configured for that particular traffic, and it is getting dropped in the slow path itself, right? So when you keep on troubleshooting such issues, so you quickly identify this. So what do, you apply the packet captures on the ingress interface and on the egress interface, then you see. And if you're able to see that it is getting captured inside the drop stage, so you should be able to identify where it should be getting dropped, because these are things which you're not able to see it in the logs, right? So either you take the dumps of the CPU to check where it is getting dropped, or if you want to provide quick resolution, then you should be checking the routing table quickly inside your, router information. So if there is no route and PBF, it is going to discard the packet. Then it enters into NAT policy lookup. So at this point of time, we are not going to apply the NAT. It will just simply evaluate the NAT policy to see, do we have any NAT policy configured for this packet, right? For this particular flow from trust to untrust, from this particular user machine to that particular destination server, do we have any NAT policy? Why are we checking this? Just to identify the flow. It is not a destination based NAT, right? If it is a destination based NAT, then again we will try to identify the egress interface. Why it is like that? Let me just give you an example here. This is the common scenario, and which is frequently asked in the interviews as well. So this is your Palo Alto firewall, right? And this is internet. We are calling it untrust. Now this is your DMZ zone where we have hosted your servers. Let's say this is the web server. Okay. ngcloudx.com is running on this server. Now people can access it over internet, right? So when the request is going to hit here, so first what will happen when you open your browser, you just hit you know ngcloudx.com. So DNS is going to resolve for this, right? And let's say you have got the public IP which is configured on this particular interface, right? Then your browser is going to prepare the request. So TCP SYN you will receive on this particular public IP, right? Now, when you have received this SYN on this particular IP, now your firewall will start the processing. And now this is inbound connection. Okay. So firewall, if you have any destination based NAT to allow this particular inbound connection, because by default it is blocked, right? So you need to configure the policy, you need to define the NAT, then only you can allow this particular communication, right? So you must have configured the destination NAT where, as per your initial original packet, this is your destination interface, right? Because your source is coming from internet and your destination is going to be this on port, let's say 443. This is your destination socket. When it hits the firewall, it will redirect this packet towards this DMZ interface, towards this actual server, right? So that's the reason we need to check for this thing, because your egress interface will change here, right? This was your flow. Your packet was coming from the untrust towards the untrust, but after the processing, it will go towards the DMZ, right? So that's the reason here we are checking for the destination NAT. If you have configured the destination, I mean, if this is for the inbound connection, then we need to do the forwarding lookup again to get the post NAT egress interface and zones. So here is the catch. In Palo Alto Firewall, when you do security policy evaluation or you configure the security policy, we configure pre-NAT zones, pre-NAT IPs, and pre-NAT zones, right? Pre-NAT IP, post-NAT zones in your security policy. And for NAT, it will be post-NAT egress interface and zone. Then only your rules are going to take hit. Otherwise, you will just keep on configuring the rules and they will not take hit. Okay. I'll come to this point with the help of the example as well to give you more understanding on this, right? So in our case, this is not the destination NAT because LAN user traffic is going over the internet. So it is purely outbound traffic, right? So it will not enter into this stage. It will directly go to this particular stage where we check for the authentication policy, right? So few organizations, it's like, to identify the user ID, either we integrate our Active Directory, right? Either we, you know, define authentication mechanism so that we learn the user ID. If you don't have anything, then you can configure the captive portal, right? So whenever you go to any hotel for stay, or let's say whenever you go to any coffee shop and you connect to their Wi-Fi, you get the initial web page to enter your username and password. That is the captive portal page, uh, which is requesting you to enter your details so that you will be provided the internet access. So if you have configured the authentication policy, then this captive portal will be triggered and you will be presented with an authentication page, and it will ask you to enter username and password. Okay. Once you have authenticated yourself, now your authentication mechanism could be anything. It could be AD based, radius based, uh, it could be, Active Directory, Okta, single sign on, SAML, right? Once you have authenticated, then we are going. Yeah, Jay, tell me.
Yeah, so I have a question about the application cache. Like you mentioned in slow path, now slow path session is new. So
Mm-hmm.
how does the application cache comes into play? Because Palo Alto will do the application decoding in later stages, not at this time. So I think it should only check the ports, not anything else. Or
See, I was about to come to that point later on, but let's
okay,
say,
okay,
if I mean people are having doubt, let me clear it right away. So what happens right now? What we are discussing a scenario where this firewall has been booted for the first time in the environment. It is having no information about it, right? So when, let's say, we have this user J, and J is trying to access facebook.com, right, for the first time.
yes,
What is J's IP address? 192.168.1.10, and Facebook will remain something like 1.1.1.1. Okay. For the first time when we are doing the processing, you have been through all the phases. We have identified the application for you. Everything has been done. Entire packet processing has been done for you. Now what happens in the evening? You again open Facebook. Now, to expedite the process of app identification, why we are expediting these processes? Because these are heavy CPU cycle consuming processes. Now to increase the performance of the box, we have created this particular cache to identify the username and to identify your application. So since you have already visited this website in the morning, and now you're trying to visit it again in the evening, so with certain parameters, it will be able to take it out this information at slow path stage itself, because this is going to be a new connection. Understood?
yeah,
So similarly, it might be the case that now, um, Debbie is trying to access Facebook within your infrastructure. Okay. So now to expedite this process of identifying the Facebook, if destination IP is same, destination port is same, protocol is same, we can identify it as that particular application. Because see, to identify the application, you need at least 10 to 15 packets. SYN acknowledgement doesn't carry datagrams. You know,
yeah.
their
Right.
data payload is 0. So you would need HTTP GET request, which is actually carrying your data, and then only you can, identify the. You can run your pattern matching signatures algorithm, and you will be able to identify the application. I hope it is clear now.
Yeah, it's clear. But one thing, like, means, is there any condition that it should fall into the same firewall rule, or it can be different rule as well for
We are not checking the rule. We are just checking the,
cache?
we're just
Okay,
checking the cache, just to
okay,
expedite. And if you see here, what I have written. IP user and user group cache, is it is going to check if ingress zone has enabled the user
yeah,
ID. User ID is enabled. It will quickly check within that cache whether this IP we have the user IP mapping, what user is logged in currently into this particular IP address, right? So you will be able to pick that information from here, because user ID daemon will be running, and it is continuously working to update this particular cache for you.
And if
So there
user
are
ID is not enabled, is the same
then we
thing
will skip.
or?
Then we will skip.
Okay, great, great. Thank you. Now I got everything.
Yeah.
Thank you.
Then again, next step, it will check for the application cache, right? And identify application if matched with destination IP, destination port, and protocol. So see, exactly, uh, we have standard applications like Facebook, YouTube, Google. These are standard applications, standard IP addresses. So we will be able to recognize them very, you can say, quickly. But if I talk about my website, ngcloudx.com, that has been designed in a way that, it has been proxied at each location. So all the time you will get a different IP address, and it will be different for each user as per their geography, right? So in that case, it will become really difficult for the firewall to identify the application. Okay, because we are just doing a basic check here. Destination IP, destination port, protocol, right? So if you get the same IP address for any application which is well known, then you will be able to identify the application at the SYN packet itself. Otherwise, we are going to follow the entire application identification process.
Yeah, great. Thank you.
Okay. Yeah, Deepak, tell me.
Yeah, just like addition to the J question, like is there any timeout that is configured for this application cache? And as you
Yeah,
know that
time.
like that, yeah, as you know the traffic is like very high in the production network. So where exactly
Yes.
it is storing the traffic, the cache?
Yeah.
So
So
can
basically,
we
we have the timeouts associated with it, right? And it works on the strategy, least recently used will be flushed, right? So basically, in this cache, we are storing the information. Let's say I've stored J's information. I'm talking about the user ID cache. So J is logged in into this machine. This is my table. Deepak is logged in into this machine, right? This is stored in my cache. Now we have the timers associated with these entries, and it works on least recently used LRU algorithm, which says if J is frequently visiting this, J is frequently initiating the traffic, this timer value will be reset, right? Similarly, if Deepak is frequently visiting the, or frequently generating the traffic, this timer value will be reset. Otherwise, after some time, it will be flushed from the cache, because this cache has limit, it cannot store all the information inside it. I hope it
Hello.
is clear now.
So,
yep.
in current environment, there are many applications which is hosted on the CDN, and it is a in nature it is a dynamic.
Hmm.
So, it is helpful on that case or not?
No,
Because
this is what
IP
I
is
told
getting
you,
sent
right?
frequently
See,
for
this is what I
application.
told you.
Okay.
NG CloudX is hosted in CDN only.
Okay.
Every time you will get dynamic IP addresses. So basically, my server is behind the proxy, cloud proxy. You know,
Okay.
so as per your geography, you will get the different destination IPs. Okay,
Okay.
so in this particular scenario, it will not work. See, the caches
Okay.
are there just to expedite the process. If there is a match, it is good. Otherwise, we have the detailed flow where it is going to identify the actual application and actual user.
Okay, okay. But I think it is somehow it is validate the wrong application if it is a dynamic in nature. Like earlier, I am using another website which is provide the same IP, which later on that assigned to this URL or
See,
this application.
I told you one thing initially, that these caches are designed in a way to keep the well-known sites information.
Okay, okay, got it, got it. Thank you, thank
NG CloudX is not available in Applipedia of Palo Alto, right?
you. Okay, okay.
Yeah, we have another query. Ashish, tell me.
Yeah, hi Rohan. So Rohan, I wanted to know like if your application is hosted on CDN and we want to troubleshoot like any issue. So how
Mhm.
logs will come to? I don't think so. Log will be coming to our firewall because traffic will be served from the CDN itself, right?
See, now we are going on a different track, but it's a good question. Let me explain you. So I'll take help of my environment. You know how NG CloudX is working. So basically, my server is in US. Okay, I'm using Cloudflare. Now, Cloudflare network is very big. So why I did it? Because my traffic is coming across the globe. We have Indian candidates, we have UK candidates, US, Canada, Australia, Netherlands. You know, I'm receiving traffic across the globe. Either I should have my servers, you know, in each region, which is going to increase the cost for me. So what I am doing, I have hosted my application in one of the server in US, and this server is connected with this proxy, cloud proxy, and this is the CDN. The network is big, it has its own nodes everywhere, regional nodes, right, to deliver your content. Now, let's say if you are coming from India, you might connect to this node, and whatever web pages have been cached, let's say homepage is cached. So, first time when you visit my website, it will load slowly, but next time if you open it up, it will be very fast because that homepage gets cached in this particular node, and the next time you hit, you get the page from here. But if you need any dynamic information, then it is going to relay the information towards my server, right? So now you are saying that how you can troubleshoot that particular issue when your dynamic IP changes. See, these IPs doesn't change so frequently. Reason being that if you're coming from India, it might be possible all Indian users within that region might be connecting to this node only, right? And the IP addresses you are getting, they are valid for 24 hours. They will refresh after 24 hours, right? So for troubleshooting, you can do it easily. There is no problem in that. I hope it is clear.
Yeah, Rohan. Thanks.
Similarly, if you're coming from UK, so you will connect to this node, you will get a different set of IPs. Then from Canada, you will get different set of IPs. So why I have implemented this to protect my resource from cyber attacks as well, because these nodes are giving me the protection as well from the cyber attacks. You know, brute force, DDoS, DOS, and it is also helping me in reducing the loading time of my website because the content which I keep on uploading on the server, it makes it heavy, right? So this is how we can implement it. Okay. Now coming back to the packet flow. So if you have configured the FT portal, it will give you the page to authenticate, right? And once you have authenticated, then it is going to check for the DOS protection, your policy lookup. So pre-NAT IPs, post-NAT zones. Whenever you are configuring any security policy, DOS policy, authentication policy in Palo Alto Firewall, you need to make sure that in your rules, you define pre-NAT IPs and post-NAT zones. Then only it will take hit. Otherwise, it will not take hit. Okay. And in the case of destination NAT, it will be post NAT egress interface and post NAT zones. Okay. So then we are going to check your threshold values. So if your DOS protection profile is configured and any of the threshold value has met, you know, we have multiple thresholds. So if those thresholds are met, then your packet will be dropped because it DOS protection is enforced, right? If no DOS protection has been enforced, then you enter into the security policy lookup. So like I told you before as well, we're going to use pre-NAT IPs and post-NAT zones, right, to do the security lookup. And if your application is set to any URL category set to any, we will use this match criteria for matching your rules. And your security rules are always matched from top to bottom in Palo Alto. and it will also skip any particular rule whose action is not set to allow if the match is triggered with the help of URL or application pattern matching, right? And if there is no configured rule, then it will going to hit your default rule. So we have interzone, which is deny by default, and intrazone, which is allowed by default, right? So after you're evaluating your security rules, then we will check for the action. If your action is allowed, then only we are going to create the session for you, right? Now we have identified the flows, client to server, server to client. We have calculated the flow keys here. We have taken the hash of the six tuple and we have installed those six tuples in our database. And now you will get a unique session ID for this particular connection. Now from where it is coming, see this session pool is limited in firewall. So basically in your RAM, random access memory, right? We have a pool. So this is your session pool, and each box has its own limitation of session. Let's say this box can only have 512 sessions concurrently, right? So one ID will be taken out from this pool and will be associated to this particular connection. See, this is the limitation created by the Palo Alto. One of the company in US, the engineer got the root access, and that's the reason they have blocked the root access for open market. Only TAC engineers can get the root access. For Cisco, it is open. For Checkpoint, it is open. But in Palo Alto, it is blocked. You need a token ID to get into the root mode of the kernel. So basically, what happens? That particular guy, he got the root access, and he lifted this particular restriction on the sessions. And that firewall, which was saying that it can only have 512 concurrent session, that firewall supported almost 4,000 sessions. And later on, they, went to court and filed the case against Palo Alto regarding this. Then, Palo Alto had to pay the penalty for that. So later on, they restricted this root access to TAC engineers only. Okay, so this can be lifted up, but you should be very sound in coding. Then only you can lift up this restriction. Okay, so one unique session ID will be associated to you. This session ID is going to have these flow keys: client to server, server to client, right? And then your timeout, URL category, NAT rule, application details, all these details it will have. Okay, then it goes into tunnel inspection policy. So do we have any tunnel inspection policy configured? If yes, then it will check for the protocols, GRE, GTP, IPsec. Why do we do that? Mostly in few production environments, you will see people are running GRE over IPsec. Now, two tunneling protocols are being used together, right? Now, to take out the actual datagram, IP datagram, you need to decapsulate these protocols, right? So that's the reason, here we check again. If you have configured the tunnel inspection policy, it will check your protocol. Then it will check whether maximum level has been reached, right, of decapsulation. If not, then it will perform the tunnel decapsulation and it will again send the packet back to that first stage, zone protection check, user ID check, and all that stuff, right? Once your maximum level reached, so in our case, this is the SYN packet, not a tunnel packet. It will right away go to this stage after creating the session. It will come here, flow state in session table, right? So it will directly come here after creating your session. So your session has been created, a unique ID has been allocated, and it has been installed inside the session table. You can also check the session details by running the command show session all, And if you want to see a particular session, you can run this command. So show session ID and that particular ID, and it will give you the details of that particular session. What is the application and other things. Yeah, Jay.
So are we talking about the SYN packet here only about all these process or other mode?
See, I was just walking you through the different modules we have inside the slow path. Right now, we are just doing the processing for SYN. So for SYN, this tunnel will be skipped, right? And these decapsulations are not valid for SYN packet, right? Because it doesn't have data.
Okay. So my understanding it means it should be like synac act. After that, firewall will check, or by the first packet, SYN packet, it try to make a session.
On the basis of SYN packet only, you will get the session.
Okay. After that, and other acknowledgement arrive, then it would do anything or not. Synac act means when it
I'll
call a
I'll
syn.
I'll give you all the information.
Okay.
In
Okay. Great.
fact, I have these debugs here. If you can see on my screen, you will be able to see the actual processing TCP SYN. Then we have SYNAC. These are the debugs
Okay.
of the
Okay. Thank
CPU,
you.
TCP acknowledgement, right?
Yeah, I have multiple doubts about means this, and one
Yeah,
curiosity has.
it will be clear once you go through the flow, right? It will be clear. Right now, I'm just telling you the SYN processing.
Yeah.
Then I
Okay.
will tell you the SYNAC processing, then acknowledgement processing, then HTTP GET or SSL. Okay.
Thank you.
Okay. So after creating this session, we install it inside the session table, and session gets installed. Then here we check for the session state. So if my session state is opening, active, discard, then only I'm going to reset this particular timeout. Each session has its own timeout value, right? TCP has 3600 seconds, UDP has 10 seconds. You can check out those default timeout values in the firewall. If it is free, these are the transient states: free, closing or closed, right? Or and opening. So stable state are two states: active and discard. Rest of the states are transient states. Means from one state you're going from to another state, right? So if your session state is free, your packet will be dropped. If it is closing or closed, for time being you have not received any particular packet, then again you will be redirected towards the slow path. Since this is our first packet, TCP SYN, we have created this session, we have installed it. The session state will be active for us. So in that case, we are going to reset the timer, and then we will enter into fast path, right? Now your SYN packet has entered into this fast path. We will, okay. So we will do the layer 4 processing. We will apply the NAT now. So we will run the address port translation here. If there is any sort of error, we will drop your packet, right? And then your forwarding lookup will be done for client to server, server to client packets. In our case, it is client to server. If there is no route or any zone has changed by any anomaly, your packet will be dropped. Then we will check whether session is flagged for proxy. Then only your proxy engine will be kicked in to do the decryption. If not, then we will check for the application identified in this session. So now this is SYN packet. It is not having the data information. So you cannot identify the application, right? So here, when we do this check, it will say application identified in this session. No, it will try to do the app identification, but you don't have data, right? So when you don't have data, you won't be able to identify it. So to correctly identify your application, you need at least 10 to 15 data packets, right? So for SYN packet, this entire module will be skipped, and then it will enter into CTD flags or layer 7 enabled in this session for deep inspection. Again, SYN is not having that information. So this will be skipped. No flags are set for SP3 engine. And then directly it will enter into your egress stage. That is your packet forwarding stage, right? So it will identify your egress interface. It will apply the routing. It will do the whatever routing needs to be done to forward the packet out of the box, right? And then it will do the reassembly of the fragmentation. If any fragmentation we did at the ingress stage, it will apply the traffic shaping QoS policies, and then it will check if it is tunnel interface, right? If my traffic is going over the tunnel or not. In our case, it is not going over tunnel, so your traffic will be transmitted. So now let's see here the actual SYN processing in the Palo Alto firewall. It is visible to everyone, or shall I zoom it more?
It's
Hello?
visible.
Okay.
Easy.
So this is the SYN packet which we have received. Now you can see packet received at ingress stage, right? Tag and type, I will cover how these getting scheduled inside the the hardware, the actual CPU, and how the parallel processing is done. What is the meaning of ordered? What is the meaning of tag? Right. Then you can see your packet info, length, interface, VSys details, your work queue index, right? Your packet buffer details. Okay. And this is your packet decoded dump, which you can see your L2 information, your IP information, your TCP information, your TCP options, and then it entered into flow lookup just to check do we have any session. No active flow found, and queue to create session. Now this means we are going into slow path. Packet received at slow path stage, tag, type, atomic. Now you can see both tag and type has been modified, right? So I'll come to this part. What is this? Why it is important, and how it is working in a parallel processing. Then again we do this, we take the packet decoded dump, right? Session setup, vsys 1, session setup ingress interface ethernet 1 by 1, egress interface ethernet 1 by 1, zone 1, NAT policy lookup, matched rule index 1, destination NAT translated IP, PBF lookup. So basically this stream I have captured for inbound connection. I mean, I'm coming from internet towards my internal service. So that's the reason here you can see my ingress interface and egress interface was same. This is the example of destination based NAT. So you can see destination based NAT has been identified, and this is the translated IP, the actual server IP. Then we did the PBF lookup with application none, session setup, egress zone 2 for netted IP. Initially it was zone 1. Later on, we have identified the correct zone for this destination-based scenario. Translated IP in zone 2, egress ID 17. Okay, so these are your CPU interfaces, logical interfaces. Your physical interfaces are mapped with the CPU interfaces. DOS policy lookup, no rule matched, let packet go. Policy lookup, matched rule index 1. So we have a security rule which allows this particular packet. Tunnel inspection, do TCI lookup policy, app ID 0. We have not configured it. Allocated a new session, and this is my session ID, right? Set exclusive video in session, packet matched VSys 1 NAT rule, destination translation from this particular IP, we have translated to this particular IP, created session, enqueue to install. This is my work queue entry. These are the details. And now your session will enter into, your packet will enter into fast path. Are we clear till this point?
Yes.
Ron, like, how did we get this packet? Is this the like the full flow packet?
I'm not able to understand what you are
Uh,
trying to say.
how did we get this capture packet from
You,
ingress?
you mean to say logs?
Yes, yes, yes.
Yeah, these are the CPU dumps, your Palo Alto
CPU.
DP CPU dumps. There is a set of commands which we run. We call it packet diagnostics. So basically,
Yes, yes, yes.
Palo Alto has provided you multiple options, to troubleshoot the problems. Packet capture is there. Then your GUI. interfaces there where you can check the traffic logs and all that stuff. At last, we take these dumps, to understand what is happening with the packets, you know. Then it enters into the fast path, and again, this information is here. And now you will see IP checksum valid, DOS profile null, NAT session, run address, port translation. So now we are going to apply the NAT. Then syn cookie if configured, your kept portal deny, right? Forwarding lookup ingress interface is 16. So these are the logical CPU interfaces. Then L3 mode router 1, which is having the details, route lookup in router 1 for this particular destination. We found the route, resolve the ARP entry found on interface 17, and we transmitted your packet. So here you will see that we have not done any app identification. We have not went into deep inspection because your TCP SYN packet doesn't carry any data. Here you will see data length is 0. Okay. Now we will see SYNAC processing. In the same way, your SYNAC will be processed, but it will be little bit different this time. When we receive SYNAC from the Facebook server, it will be received at ingress stage, tag, type ordered, packet info, work queue entry created, right? Then we take the packet decoded dump, source IP, destination IP, source MAC, destination MAC, all these details. Then your flow lookup, and we found this session ID basis on your flow key, right? Because we have already created the session and we have installed it. And if your session is active flow, it will directly now enter into the fast path. The second packet will not go inside slow path. So slow path is only for first packet, and it is a journey to create the session for that particular connection. Once we create the session, we install it inside our session table, then all the subsequent packets will directly go from ingress towards the fast path. They will never enter into the slow path again. Until or unless your session state has been changed from active to closing, closed, free, or something like that. Then only they will go back to the slow path. Are we clear?
Yes.
Hello?
Yes.
Okay. So then we directly enter into fast path. Then all these checks regarding DOS, then NAT session, run address, source address, port translation, SYN cookie, forwarding lookup, L3 mode, router 1, route lookup. We found the route for this particular IP address. Route found. This is the interface. Zone 1 next hop is this. Resolve ARP for this. ARP entry found. And we are going to transmit it. So here you see this is Ethernet 1 by 1. This is your physical interface. And these are your logical CPU interfaces. Okay. So when we are sending SYNAC, it means it is going from inside to outside. So destination interface is 16. When we were receiving SYN from outside to inside, my destination logical interface was 17. Okay. And it was mapped with Ethernet 1 by 2. Okay, so after transmitting SYNAC, the client is going to send these acknowledgement packet. So just to give you the brief about it, it is going to be like this. So we have sent this in on interface 1 by 1. Palo Alto has done the processing, transmitted out, right? Then Facebook has sent this SYNAC. It has done the processing. Then client is going to send the acknowledgement to establish the session. Okay. So now we have received the acknowledgement packet from the client. This particular dump is different. This is depicting a inbound connection from inside towards my DMZ server. So packet received in ingress stage, active flow, flow found, right? This is the session ID, NQ to fast path process, and then we will enter into the fast path. Here you will see we have entered into the fast path. We have applied the NAT. We have done the route lookup, resolve ARP entry for this, transmit packet to the server, and our TCP three-way handshake is complete, right? Now, generally over internet, we have SSL, right? 85% of internet traffic is working on SSL. So after your successful TCP three-way handshake, your SSL handshake starts. But in this decode, just to simplify the things, I have taken help of port 80 website so that we can see the actual HTTP GET request, how it is getting processed by the firewall. Okay. So now with the help of whiteboard, I'll explain you this in more detail. So now your actual, app identification and deep inspection is applicable. So basically what happens if your traffic is going on port number 443, we will configure the decryption for that. Then only you will be able to identify the actual application and you will be able to do the deep inspection. If you have not configured the decryption, then you are just doing the sanity checks. You are not able to do the actual content threat detection on that particular packet, or you can say you are not able to apply the security profiles on that particular packet, right? So basically what happens after your TCP three-way handshake, you will receive the HTTP GET request. Now we are discussing a scenario when you make a connection on port 80 website, right? So after TCP three-way handshake, your HTTP GET will come. So GET is going to hit, so GET will enter into the ingress stage. Again, these things will happen. And then we will find the flow for that. We have the session ID allocated and it will directly enter into this fast path here, right? And we will do the processing. And here, now you will see application identified in this session. Still, we have not identified it. It will send it to the app ID module. And here, the first thing we check application override lookup match. Now, why do we create application overrides? So basically, this is the CPU extensive process. We do regress pattern matching, right? So for custom applications, let's say NG CloudX, it's not a well-known application and we don't have entry of this application. This is the web application. We don't have entry of this application within the Palo Alto database, application database, which we call it Applipedia, right? So when you don't have information of this particular application, again and again, firewall is trying to identify this application and it is failing to do that, right? So what it does, if it is normal port 80, it will call it as web application. If it is on 443, it will be identified as SSL. If you're not able to identify the well-known application. If this traffic would have been for facebook.com, then your application would have been identified as facebook.com or Facebook base if you are opening the home page. Similarly, YouTube base. These are the well-known applications. And you have Google base. For unknown websites, unknown applications, either it will be web for port 80 and it will be SSL for 443. Now, why do we create application override? So when you have DNS traffic in your environment, so DNS is like very chatty, not chatty, but the volume is very huge in any production environment, right? So if Palo Alto is keep on doing the app identification for DNS, it might lose, the performance might degrade because, it's like CPU cycles are getting wasted in identifying this particular application. So with the help of this application override policy, you can bypass the app identification for this particular application. And initially, someone has asked me this question that what about the custom applications if firewall is not able to identify the application correctly? It might hit wrong security rules because we do create security rules based on applications, right? So that might be the possibility. So for your custom application, firewall might identify it wrongly and a wrong security rule is taking it, or a security rule is not taking it and default rules are taking it. In that case, just to remediate the problem, you can create this override and bypass the app identification for that particular traffic flow. Is it clear to everyone?
Yes, Ram.
Yes, it is clear, but we have some doubt. Like without SSL decryption, we cannot able to identify any application or apart from well-known. Because I have seen
The
that,
well-known will be able to identify
but
Facebook, YouTube,
how
Google.
the well-known is will identify? I didn't understand this. If this is an
Okay,
encrypted set,
okay,
how?
I'll tell you. So
Okay,
basically, what happens?
okay,
Uh, okay, so this was the right question, and I was expecting someone to ask this one. So basically, what happens when you don't do SSL decryption, right?
okay,
So what happens after this TCP three-way handshake? We are going to send this client hello.
right.
This client hello has one extension field which we call server name indication, and
SNI.
this extension SNI has the domain information.
Okay,
So firewall picks this information from here, and basis on this domain, it identifies the application and it will give you the application name as Facebook base. And basis on this information, your URL filtering can be applied as well if you don't do decryption.
okay.
Okay. Yeah, Debbie, tell me.
But
Yeah, Rohit,
in
like let's yeah, sorry. So let's say we are doing some not a SL based. Let's say we are doing some secure LDAP, or let's say secure tunneling. So in that case, can the Palo Alto come to know what application it is using?
No,
We're not doing the web browsing. Other thing it
no.
is happening.
On that basis, it will try to identify basis on the destination, port number, right? And if you are making a SSH connection, it will give you the SSH app ID assigned to it, right? LDAP connection, like that.
Okay, but it can properly detect in that case.
No, it won't be. See, if you need granular control of any application, be it web application or any other application, you need to do the decryption. See, initially without decryption, it will be able to identify the app here as Facebook base. That can be done. But if somebody is opening Facebook chat, Facebook games, firewall won't be able to identify it. Reason being that you have not configured the decryption here, right? Once you configure the decryption, your proxy engine kicks in place. It does the on-fly certificate pinning, and with the help of that, it will be able to identify now user is opening Facebook chat, now user is opening Facebook games, and accordingly you can configure your policies. So your URL filtering, your app identification and policies based on your applications will not work efficiently if you will not configure SSL decryption.
Okay.
I hope it is clear now.
Yes, sir.
So guys, थोड़ा boring तो नहीं हो रहा ना? I mean, it's like interesting
No,
or
no, it's great, interesting. Actually, I have
okay.
one question also. Like SNI
Mm-hmm.
field is enabled only in this client hello packet. So
Yeah, it
if
is
it's not
the
there,
SSL. Hmm.
yeah, so if it's not there, I don't think that it will be able to identify.
For SSL, it will be always there inside the client hello. These are the extensions we have inside the header.
Yeah, but nowadays site doesn't have SNI. Mainly they have SAN. So would they be able to identify or not? Means would be Palo Alto.
See, that alternative name, it's part of the certificate, right? This is the packet coming from your client. Client is preparing this hello packet, and inside this packet, when you drill it down, you will be able to see there is one extension called server name indication. And that particular indication will definitely have the domain details where you are going to make the connection with. Because on the basis of this domain information, I'm going to validate the server certificate as well, which I'm going to receive it in the next packet from the server.
But sir, we have applied the as a IPS profile as well, so it will able to detect the layer 7 attack as well without decryption. So how that is work? I have a sub
I'm
confusion.
I'm I'm coming to that point only now.
Oh,
If
okay.
you will, yeah, if you will allow me, then we will see this entire app ID process, and then we will go inside the CTD.
Sure,
That is
sure,
your SP3 engine single pass parallel processing.
sure, sure.
Okay. So application override is clear, right? Why do we create the bypasses? So just to fine tune your uh, firewall processing, you can bypass the huge volume applications like DNS, ping, right? And you can also bypass your custom applications so that wrong rules should not take hit for these custom applications. Okay. If there is no match, in our case, there is no match in the application override, it will enter into pattern-based application identification, right? And here you will see update app ID cache. So you were asking me this question before, right? How this app ID cache gets updated. So basically what happens now,
Yes.
now these CPU components here you see. So this Octeon chip will now communicate back and forth with this signature match chip. It could be Ocelot, Jaguar, it depends. If the lower end boxes, they don't have these dedicated chips, it is done at OS level. This pattern matching is done at OS level with the help of the algorithms AHO and DFA. And in latest operating system, we have a different app algorithm, PScan. So these are the pattern based, matching algorithms. When you have a dedicated chip, your operations, your process gets accelerated. If you don't have chip, then all these processes gets executed inside your CPU only. So your firewall performance degrades. Okay. So that's the reason higher end boxes have these chips. Lower end boxes, if I talk about 200 series, 400, 500, they don't have it. Okay. So once we have identified the application, let's say in our case it is facebook.com. And how we have identified it? We have identified it with the help of the SNI field, right? It will allocate the application as Facebook base. It is going to update that particular app ID cache. It will say that this destination IP, this destination port, if users are going on this particular destination socket, then probably they are going over Facebook base application. And it will associate a timer to it, to that particular entry. So the next time, if users are trying to access Facebook other than Jay or Ravi, they will be, the firewall will be identify the application as Facebook base, right? And then if there is a shift, then it will detect that particular shift as well. Now we have identified your application, and that's the reason. If you see in the slow path, we have this line statement written here. It will skip any rules with action not set to allow if the application or URL category causes the match. If for the first time I'm initiating the connection, how firewall was able to identify my application? Makes sense? Because of the cache. Hello, guys.
Yes, yes. I think it makes sense now.
Could you please repeat that again?
Sure, sure. So it's like here in the slow path processing, first we have evaluated the security rules basis on pre-NAT IPs, post-NAT zones, application set to any, URL category set to any for rule match criteria. But it might be the case you have configured your security rules basis on Facebook base app. Let's say you have configured the rule that if users are going to the Facebook base, traffic should be denied, right? Now, how that particular rule will be evaluated in the slow path with the help of the application cache. For the first time, when a particular user, let's say J, is trying to visit facebook.com for the first time, in that case, this particular matching criteria will be skipped because we don't have information inside the app cache, right? Once J has done the processing, you know, let's say now Ravi is trying to access facebook.com. My destination IP, destination port, all these details have been updated in the app ID cache, which says that this particular destination IP and port belongs to Facebook base application. So for Ravi, now this particular statement will be applicable. So if we have configured any rule with this particular matching criteria, let's say Facebook base should be blocked. So right away, Ravi's traffic will be dropped. It will not waste our CPU cycles anymore. And this is how Palo Alto was able to, enhance the performance of the box.
Out like it Palo Alto checks by top to bottom. So if I think if you come to left side,
If we have 1,000 rules, and if it will start checking top to bottom, you can imagine. Yeah.
okay. So but
So
I think
we
if
have mechanisms. We have mechanism in place. These are the mechanisms by which we expedite that parsing to search the exact rule quickly.
okay, so for this application check, it will check for allow rules. Will action is set to allow, not
Yeah,
deny. It will
yeah. Just to go into session creation. If there is no allow rule, it will by default hit your default rules, and then your packet will got dropped.
okay.
Even the
And
rule which you
later,
have configured, it will not take hit.
okay, that is just for session. Session means table means to create a session. Afterwards, this application decoder and everything will happen, right? Then it can change the rule. Means it can match
Exactly,
another rule.
exactly. And this is what written here. If you see, we update the app ID cache, and then we again evaluate your security policy lookup with the application. So initially we bypassed all those rules with the application, for the first time.
Okay. Yeah, just to
And
the
here we
performance
do
issue.
the, yeah, and here we again do the lookup. And if your rule is saying that traffic should be allowed, rule match action is allowed, then only we are going to check your security profiles, whether we have configured the security profiles. Otherwise, your packet will be dropped. So Facebook base not allowed will drop the packet here. Okay. Now we will check for your security profile. So if you have configured the deep inspection on this particular traffic flow, it will flag your profile packets, profile flags. It will, apply the security profile flags on this particular session, and then it will check for your QoS policy lookup, and it will set the class and QoS marking on that, and then it will go inside your application identification. If your application has been identified as SSL or SSH, so do we have any decryption policy configured for that? Yes, no. If yes, then it will mark your session for decryption. It will check, do we have any exclusion list from where you need to bypass your decryption? If no, then it will flag your session for proxy, and then your proxy engine will kick in. So basically what all these three steps means, if my application has been identified as SSH or SSL, it means it is an encrypted traffic. I need to decrypt it. It will check, do we have decryption policy in lookup has been configured? No, then I will go back to my fast path. If yes, then I will enter into the exclusion. Now, why do we create decryption in exclusion? So if I give you an example of WhatsApp, WhatsApp says I'm end-to-end encrypted. What does that mean? So this is your client mobile and you are running WhatsApp here. This is your firewall and this is the WhatsApp server over internet. Within the code of the WhatsApp, I have hard coded the server certificate chain. Right? So when you are going to make the connection with the server, your client hello will go, your server certificate server hello will come. It will have this particular chain. If that chain matches this particular chain, then only your connection will be established. Otherwise, WhatsApp will not establish this connection. Now, WhatsApp says that it is end-to-end encrypted, but that is not the case. Because in my another live sessions, I have shown this to the people as well. When you enable decryption on firewall, this particular server certificate chain gets modified, right? And as per the WhatsApp, if anyone is going to modify this chain, then connection should not be established and you should not be able to use WhatsApp. But it still continues to work. Reason being that Government of India has directed WhatsApp to decrypt the traffic so that they can see what is going on. Otherwise, it has led to the terrorism. You know, people were sending messages encrypted, and government was losing the visibility. So you can decrypt your WhatsApp. So if there is any application which needs bypass from the decryption, like Dropbox is there, Mega is there, WhatsApp is there, you can add it. You can call that exclusion cache, and it will be bypassed from the decryption and it will directly go to the fast path. If it is not part of the decryption exclusion list, then your session will be flagged for proxy. Now your proxy engine will kick in. Okay. So now going back here in the fast path, when your session gets flagged for proxy, let's say it is SSL based application, it will right away come here. SSL proxy flagged in session. Now the proxy engine is going to implement the decryption and it will start, you know, uh, doing the on the fly certificate pinning for you, right? And then we are going to enter into this particular thing. Your deep inspection CTD flags or layer 7 enabled in this session. And it was flagged in app ID only. So here you can see all these pointers, they are going towards this, that we need to do the deep inspection. Reason being that security profile flags were set on, right? So now it will enter into the SP3, that is a single pass parallel processing CTD engine, right? And again, it will do the content and thread detection with the help of the pattern matching. It will use that particular chip only, Ocelot or Jaguar. If chip is not available, then it will use AHO or PScan. It depends on the PAN-OS version. Now again, there are decoders configured within this modules who keeps on checking for the application shift. So if application is shifting from Facebook base to Facebook chat, these decoders will be able to identify that. And again, they will go back to the app ID module. And here it will land this particular check where it says security policy lookup with the application. So if you are blocking the Facebook chat, packets will be dropped. So what will happen? Users will be able to visit facebook.com only. If they try to open Facebook chat, it will show them offline because your sessions are getting dropped for chat, right? If they try to play any game, they will be blocked as per the configured policy. So this is how decoders help to detect the application shift here. Then we apply your security profiles, vulnerability, antivirus, right? Threat. If any threat is detected, then we check for your security profile actions. So drop, reset client, reset server, reset both, packet will be dropped. Alert and allow, packet will be passed to the proxy engine to do the re-encrypt, right? Wherever applicable, and forward it towards the egress interface. Okay, egress stage. So now, after doing the deep inspection, it will enter into packet forwarding processing, right? And here we will do the route lookup, apply the necessary, layer 2 changes, and it will enter into packet egress process. We will apply the fragmentation if necessary, and it will check for the egress interface if it is tunnel. So we will encrypt the IP datagram. We will add the hash, encapsulate it, and then again send it back here. And then this process follows, and finally it will be transmitted out from the firewall. So this is how Palo Alto does packet processing. This is like at OS level, you know. If you want to see at CPU level how it is done at your chip level, and these are the processes. I will take one by one. But before that, I would like to get your queries regarding this, and then we will see how it is done at chip level. Yeah. Yeah, Jay, tell me.
Yeah, I think after Cincinnati Act, this means after the fourth packet, this kind of decoder and application ID and everything will take place. So, like session would be one, or there would be three sessions. Like in Sin,
No,
one
only
session, only one
one
session.
session. Only
Then
one.
Synac will be reply. Sin acknowledgement will be reply. It will all be single process.
I'll show you this here. So
I
if you see this, what is the session ID? Can you read this?
36, yes, yes,
36158.
158,
Right?
yes.
This is your HTTP GET request
Get request,
after
yes.
TCP three-way handshake, right?
Yes.
36158.
Yeah.
If you scroll it up, this is the acknowledgement packet. What is the
Yes.
session ID here?
Yeah, same 36158. Yes.
If you go back to SYN packet, creating session,
Got you.
then NQ2 session creator, slow path, session setup, ingress, created session NQ2 install, right?
Yes.
And here, if you see, session ID will be there.
Yeah, I think 36159.
Yeah, so see what happens, might be I have taken the wrong TCP stream. That's why it is showing a wrong session ID number here. So basically what happens, let me take help of whiteboard. So whenever you make any connection with any particular website, so you just don't make one TCP stream with that, right? So this
Yeah.
is your client and this is the server. So when you visit any .com, facebook.com or something like that, if you take the Wireshark captures, you capture multiple TCP streams. They open and they get closed. They open and they get closed, right?
Yeah.
So it's like whenever you visit any website, there are multiple streams. For each particular TCP stream, you have a unique session ID. Okay. So I think I have taken the dump of subsequent TCP stream here. So that's why it is showing 36159 because all the following packets you will see 36158 because when you take these dumps out of CPU, you get hell lot of data and you need to take out this information out of it. So sometimes it happens. Yeah. Somebody else has
Hi.
raised the hand.
So how CTD is able to detect any antivirus, any vulnerability without decrypting the traffic or IPS
It
profiles?
won't be able to do it, right?
It won't
You
be.
have you have seen here
Mhm.
when we enter into this application identification,
Mhm.
it checks here. security profile flags on session. Let's say you
Okay.
have configured the security profile, right? And your application identified as SSL or SSH. Okay, this is the encrypted traffic. And if you don't have any decryption in place, it will right away go to the CTD flags or layer 7 deep inspection is enabled. And then it
Mhm.
will come into this content and threat detection, right? When
Okay.
my payload is encrypted, what pattern matching you're going to do on that?
Okay. So in that case, IPS or antivirus in any content profile didn't work, right?
Deep inspection is not possible. I mean, although you have configured it, but it won't
Okay.
be able to detect anything because the payload is encrypted. Makes sense,
But
right?
makes sense. But I have seen that layer 7 uh, vulnerability is detecting without applying the decryption
So
policy.
those are the predefined things, in database, in Palo Alto database, you will see we have the information for malicious IPs, malicious URLs. Those
Okay.
databases are there in the
Okay. So
security
how that
profiles.
malicious URL they validate upon the what thing they check on the traffic pattern?
Exactly. So basis on your destination IPs, destination ports, your SNI fields, they try to pick up the domain information from there, and
Mhm.
accordingly, they are able to imply that particular enforcement of security profiles, without doing the decryption.
Okay. Okay, so well-known thread will be detected without applying the decryption policy, right?
Yes, that's right. Well-known things will be detected without decryption. If you need more granular control, more deep inspection, right?
Like
Then
a
you need to do
zero
the
day attack will not be detected if we don't apply the decryption policy, right?
that's right.
Okay,
because that
makes.
because that thread signature is totally new. It is
Mhm.
encrypted inside the session. It will hit this content and thread detection, right? Payload is encrypted. It is not able to see the actual content. Sandboxing is also will not going to help you here, right? So it will bypass everything and it will get inside the infrastructure.
Okay, thank you, sir.
Okay. So now coming your layer 7 processing. So this is how your HTTP GET request gets processed, you know. So we have received the packet in ingress stage. Then we have found the flow session was there. We entered into fast path, right? And we applied the NAT. Then it is going to call the functions, you know, whatever security, whatever layer 7 configuration you have configured on it. Accordingly, those respective functions will be invoked during your CTD and fastpath processing. So here you can see your PAN URL filtering match got triggered, and it was cybersec.com, which I was trying to access, right? So then your deep inspection comes into the picture, your layer 7 inspection. I mean, these debugs are still very limited. When you take full dump, you will go mad. There are so many functions, so many processes which gets invoked just for processing one packet of a stream, you know. So just to keep the simplicity here, I have only picked up the logs which you can understand, because I do have an advanced troubleshooting course available where I have captured everything. There you might see all the debugs, in-depth information about it, how it covers all these things, right? So for just for simplicity, here I have kept few things only, right? Then you can see we get the acknowledgement from the server, right? And fast path, normal processing. Then we get the HTTP GET response from the server. Okay. And once it enters into the fast path, this is the process, right? So if you have configured the any deep inspection onto this particular traffic flow, those respective functions will be triggered. So any doubt before we move to hardware processing, how these packets, because this is at the OS level, how these things get scheduled at hardware level, that is a different story. And how parallel processing is working. So if you have any doubt, just let me know here
Yeah,
before I proceed.
this was the TCP session. So UDP session, you have another slides or it remains the same?
See,
When
UDP
it
in UDP, what happens, TCP is connection oriented, right?
yes,
So in UDP, your first, whenever we are receiving the first packet, right, of any session, because these are stateful firewalls. So it will come to the ingress stage, flow lookup, slow
yes,
path, session will be created, session will be allocated to that session, then it will enter into fast path, then it will check whether it has data or not. If it has data, then it will try to identify the application, it will try to do the deep inspection on it because it has data, right? And
right.
after that it goes out from the firewall. Now when second packet coming for that particular connection is directly going to hit your ingress, from ingress it will check flow lookup, yes we have this session, it will enter into the fast path. And inside fastpath, all these things, your app identification or deep inspection, all these modules are there, and it will be redirected accordingly, and then it will be processed and it will be forwarded from the egress stage.
Okay.
So for this session I have just kept TCP stream because it is not possible to cover everything in just 3 hours, because this is very huge topic which I'm covering today.
Yes, yes.
Okay.
Okay, yeah, sorry. This is Siddharth, and I have a question in this application identification. Can you please zoom that? Yeah, thank you. So the question is like in the pattern-based application identification, the firewall is using some caches. So is there any specific timeline, like it is like storing for that caches, or it is refreshing
Yeah.
on some particular time interval? Because what I'm like, sorry, why I'm asking this question, like if user one is accessing and like Facebook, and it is stored the caches, and after after sometimes the caches cleared, then if user 2 is trying to access, then again user 2 will go and use the slow path again.
Yeah. So
Yeah,
nice question.
yeah,
If you have seen, whenever we do troubleshooting, see, if you are working for a service provider, you can do anything, right?
yeah,
But if
yeah.
you're working for TAC, when we educate our TAC engineers, or when we give them training and when we tell them how to do troubleshooting, we basically, train them to follow a particular troubleshooting approach. Reboot we recommend as the last step of the troubleshooting when you are done with everything. The
Okay,
reason being
okay,
that if you're going to reboot your firewall, or if you're going to reload any daemon, let's say user ID daemon, I have restarted it, or management server, I have restarted it. What it is going to do, it will flush your cache. And here you are just able to see user ID, app ID. We have multiple cache. We have URL, you know, URL category as well. Data plane cache is there, management plane cache is there. Then it back and forth communicates with the cloud to download the URL category. Reason being that these cache, they are limited in memory, in size. Okay. So
okay,
let's say I have a limit of 100 entries and I have updated all those 100 entries. Now, if 101 entry came, yeah, come, what can I do? I will delete the entry which is least recently used. I have not used it, or my environment has not visited that particular application. I will purge that particular entry and enter this new one. Okay.
okay, okay,
So this is how it works.
okay, okay. Yeah, thanks.
Okay. Now coming to the chip level. So I'm not sure whether you are able to digest this information or not, but I'll try to explain it as simple as I can, right? So basically what happens, this is your block diagram of motherboard of any of Palo Alto firewall. So we have physical ports connected to this bus bar, right? And then this is your packet input processing unit. These are hardware chips, which actually does processing. Then your TCP/IP acceleration block, your zip compression decryption unit, your scheduler is there, your DFA is there, right? Your dynamic RAM is there, your L2 cache is there, your packet output processing unit is there, and your CPU cores are there, right? So basically what happens, your packet comes into the receiving interface. It is sent towards the packet input unit. This input unit allocates uh, you know uh, different work descriptors. Basically what happens when your packet is coming, this is your Ethernet frame. It has information like L2, source MAC, destination MAC, source IP, destination IP, like that, and payload, right? So to do the processing, whatever processing we have seen so far, to do this, you need to store this particular information somewhere, right? So we store it inside our packet buffers. Now, where do we have these packet buffers? You have these packet buffers inside the RAM, which is your random access memory, right? And these interfaces as well, your receiving interfaces, transmitting interfaces, they have their own queue, RX queue, we call it, to store the packet when it is coming, then, regenerate the packet, send it here. So basically what happens, it goes directly to the packet input processing unit. Now packet buffer gets allocated within the RAM to store your packet. Okay. And then we are going to create a data structure. We call it work WQE, work queue entry, which points towards that particular packet buffer that, boss, here is your data on which you need to do your processing. So this WQ is telling the PAN OS that the actual data is stored at this particular location where you need to do the processing. Understood? Hello? Okay, no worries. I'll get back to this point. Then this W key is forwarded to this particular scheduler. This is the scheduler, which is scheduling the multiple jobs which can be processed by these CPUs. We have multiple cores.
So this WQ is to means it's like a queue system, first come first serve or something.
Yeah, basically, we are maintaining the order of the packets, right? We are
Okay.
storing the packets. We are telling our CPU that, not only CPU, these different modules, app ID, CTD, that where is the information stored, where you need to do the
Miss,
processing.
all this is done parallelly in real time or one by
Yeah,
one it happens?
this is what I'm going to tell you in upcoming slides, right? So this data structure gets passed on to this scheduler, right? And this scheduler then schedules the job to the CPU whenever CPU request for the work, right? So this is the high level board diagram. This is how it is being done. So let me zoom it here. So basically what happens, now comes your parallel processing and your serial processing. So whenever core request for work, it initiates one function which is get work to this scheduler. Now this scheduler, if you have seen here, we have passed on this information WQ to this SSO unit. This input unit has told the scheduler that, boss, you need to do processing on this particular packet. I have given you the data structure. And that data structure has been stored here inside the QS queues, right? Now, this is the first packet. This is the second packet. This is the third packet, right? Wherever atomic is mentioned, it means you cannot do parallel processing on this particular tag type. We have also given you the tag type. You can see 5. For this, ordered is the tag, and number is 6. ordered, and number is 6. It means for ordered packets, different cores can work simultaneously, but for atomic packets, you cannot work simultaneously. You need to work one at a time. Because during the processing of this packet, your PAN OS will enter into the critical code section where deadlock can occur, right? So core generates this function get work to the scheduler. Scheduler is going to pick up the packet which is scheduled on the basis of priority, and it will be given to this particular core. Then core is going to have its own data structure which says core descriptor. See, these data structures are nothing but they are pointing to the relevant information, right? So here you can see these work queue are pointing towards the location inside the memory, random access memory, and where your actual data has been kept, right? So now when job gets loaded into the core, your CPU gets the core descriptor and it tells the OS that boss, currently I'm working on this packet. And a new queue created, we call it in-flight queue, where CPU core is busy in doing the processing on this particular packet. Understood so far? Before I move on.
Yeah, just one thing. Like this atomic is like active connection or means is there a different term?
See, these are the tags you can say, which tells CPU whether you need to do parallel processing on this packet or serial processing.
Okay.
Okay, so atomic means serial processing, ordered means parallel processing. So in the very next slide, you will be able to see this.
Okay, great.
So when other cores requested for the work, scheduler has provided those packets, these two packets, which were next in the queue, right? And now you can see core number 2, core number 3, they are simultaneously working on this particular packets. Order 6, order 6. So they belongs to a particular connection. Here I'm showing you the multiple connections processing. This is a different connection. This is a different connection or a different sequence. So here you can see multiple cores are working on these packets and the data is stored inside the RAM here and they are doing their work inside the in-flight queue. This particular core is only working on this packet. Although these 3 cores are free, we cannot schedule this one. Reason being that, see the tag. Tag is 5. Tag is 5. But it is set to atomic. Atomic means you cannot do parallel processing on this particular data. Although we have cores available, but it will be first CPU will process this packet and then only this will be loaded here. Make sense? या बाउंसर था ये
Still thoda clear है means it's like it's bit clear but not much means like it will be deep questions like how tags are selected now that will
see,
be next question.
see, I'll tell you. See here, packet received at ingress stage. What is the tag value? 0. What is type?
0.
Ordered. Oh.
It means we can do parallel processing on this packet.
Yeah.
See, you are not going to receive the information in just one packet, right? If I'm
Right.
sending one MP3 or media file, okay, so आपका IP डेटाग्राम तो 500 बाइट 1500 बाइट का ही होता ना, so it is approximately close to 1.5 KB, but that too उतना data transfer नहीं होता. We only transfer 1.3 KB information, right? Your file size is 1 MB. So it means we are going to transmit this information in multiple IP datagrams. Make sense?
Yes.
So
yes.
if the type is ordered, we can do parallel processing on them. If the type is atomic, we will do what we will
serial
do?
processing. Serial processing.
Serial processing. No multiple cores can work together. Although we have CPU cores available, but they will not start their processing on the next packet. which
Okay.
is there in the queue.
Yeah, so for
Because
same
type,
session, this thing can occur.
yeah,
So, Ron, like when the packet which are required a deep inspection, are those packet atomic or ordered?
no. It's this has nothing to do with the deep inspection or none, something like that. I'll tell you one thing. How CPU works for basic computer architecture or any device architecture. So basically, your PAN OS or any other OS, they have been designed basis on Linux. So base operating or kernel level is Linux code. On top of that, you have created your surface layer, and accordingly, you're using this base Linux to do your job, right? Now, each operating system has one particular section because ये भी एक code है ना. PanOS is also a code, right? So each operating system has one section, we call it critical section. Now, critical section means whatever code is written here, it will go and acquire few resources. Let's say it will acquire packet buffer to do the processing. It will acquire your work descriptors to do processing. And it will acquire lock on top of it. That boss, I'm working. No other process can use it. Reason being that there is a deadlock. Deadlock means one process needs one packet buffer, one work descriptor. Another process needs two packet buffers and three work descriptors. If you don't create such locking mechanism, your entire operating system will end up in deadlock. Reason being that if this process gets one packet buffer and awaiting work descriptor, and this process has got three work descriptors and one packet buffer and awaiting this packet buffer to get freed. So it is like a deadlock that I am waiting for you, you are waiting for me, I'm waiting for him, he is waiting for you. Deadlock. And your operating system hangs. In that case, we do the reboot. Android में common problem है ना ये, reboot करके phone fast हो जाता है. iOS पे कभी problem नहीं आती. That's why Apple is selling, globally with such a feedback from the user point of view, because they have designed their OS in a way that it never hangs. Android में it is a common problem. Deadlocks हो जाते हैं, right? So similarly, in any particular device, when they enters in a critical section, which is going to do the processing on particular shared resources, we we enforce the lock on that particular resources. That boss, this process is using these resources. You are not supposed to use them. Once it is done with the processing, it will release the lock, and then you can use it. And that's the reason we are assigning these tags atomic, ordered. So atomic means during this processing of the packet, we might enter into a critical section where we need specific resources and parallel processing cannot be done. I hope it is clear now.
Yes, Ron. Yes.
Yes, it's
So, like
clear.
an example, like in case of cloud DBs, sometimes it gets hanged or we means it shows down or something. So, tech advises to you restart dev server. So, at that time, this
Device server.
deadlock can occur or
No. That has nothing to do with the
different
deadlock. It is a connection with the cloud service,
cloud
right?
service. Okay.
This deadlock is within the PAN OS,
Okay.
your operating system.
Okay. Same concepts like Linux kernel, and this is the
Same,
OS,
same.
and
See, every device, every networking device has been developed by using Linux only. That's the reason it is crucial for the engineers who are working in support role get familiar with the Linux. In Palo Alto, you don't get root access. That's the reason you cannot run Linux commands. But if you work on Cisco FTD You work on checkpoint, you get the Linux access, you get the root mode, and you can run the Linux commands there.
Yes.
So guys, that's it for today's session. So if you have any doubt, any query, you can let me know. And I would definitely would like to capture your feedback. How was it? Whether you liked it or not, so that it will help me to improve my sessions going forward.
Around one query is that, like, let's say while doing the communication, let's say the packet get dropped due to window size or MSS in Palo Alto, and which days that could come into effect.
Can you repeat your question? I mean, you are saying,
In packet communication, let's say the packet get dropped due to low MTU value, or like, let's say low, like,
so
Windows
getting dropped where? At firewall or at server level or
firewall,
at
firewall at firewall.
okay. So see, each network has its MTU value, right? So when you are sending a IP datagram, if you send jumbo frame, let's say 9,000 bytes, this broadcast domain supports it. You have configured this interface to receive this jumbo frame. But if you are going to transmit this particular packet onto this broadcast domain over internet, you can only have 1500 bytes. You cannot send the jumbo frames over internet, right? So here firewall will try to do the fragmentation of this particular packet. It will try to divide it into multiple fragments. If do not fragment bit is set, then firewall will drop it. It will give you the message that fragmentation is required, but DF bit is set, right? So this is how we do the configuration.
And in log, what we will see?
You will see the log here in your machine
Okay, here.
itself.
Okay.
It will give you the response code. Fragmentation is required. I mean, you can do this test. It is very basic. Just do one thing. Connect your laptop with firewall with internet access, and with ping, just try to send the payload over Google of 5,000 bytes, and you will see you're getting the messages. If DF bit is set to 1, then it will be dropped. I will cover this part in my upcoming webinar, that is TCP IP TAC level. So all these scenarios will be covered there live.
Okay. Yeah, sure. Thanks.
Anything else, guys?
Hey, hi Rohan.
Yeah.
Rohan, can we get the recorded session?
Yeah, we will. I'll give you the recording.
Okay, thanks.
So basically, guys, let me just see here. When you visit ngcloudx.com, so I have redirection in place. You will be redirected to ngcloudx.in automatically. See, this is how it is. If you hit ngcloudx, so see, this .com is for the global community. If you are from India, you will be redirected to ngcloudx.in website here, right? You get the information of upcoming webinars here. You can click on registration. You can register for your webinars. And here I will add one more option where you will see the recording link, right? So let's say here you get course and login option. So if you click on course, it will redirect you further to my main website where I have hosted the courses. And you can just provide your user mobile number, login, and you will be able to see the recording, right? And we do have this TAC advanced course available, this advanced troubleshooting course available, which covers everything in depth, hardware architectures, troubleshootings, everything is like beyond TAC, you can say. Okay. This course is also available. You can go and check it out if you feel like that you need this information. It has KB articles, handwritten notes, everything is there. Okay. So recording will be available, and when you will log in into this website, here you will get the option webinar recordings. Are we good?
Yeah,